is a little segue into the chapter, but it uses what we did last chapter, okay? So we'll have some familiarity here in a second. Here we go. So this is a standard proportion, right, that we've used all last chapter?
Yeah.
But now we have special names for these little parts. So when you say A over B equals C over D, the two ends right here, A and D, are called the extremes. And the two in the middle are your means. And by what we mean in the middle is when you say it, A over B equals C over D. B and C are in the middle when you say it out loud. So that's just a little vocab for you. The means and the extremes. Now a geometric mean is when the means in a proportion are the same. So a geometric mean is when the means in a proportion are the same. So instead of writing C, what would I write? B, right? Because I want my means to be the same. Okay. And if I wanted to solve that, I would get, what's B times B?
B squared.
B squared equals A times D.
Yeah.
Maybe I'd write that down. That might be a good idea to write down somewhere in the blank space. So really, when you're asked to find the geometric mean of two numbers, it wants you to multiply those two numbers, and then how would I undo a square root?
Square root.
Right, so then I'd have B equals the square root of whatever A times D is. So let's practice that. I think that's our next example. Find the geometric mean of 5 and 45. You guys want to calculators? How does that work?
So,
Oh,
5 over B, then
got one?
I love it. The cool part is you can barely tell it.
I have those all the time.
Okay, so now let's try this out. So remember, if I want to find the geometric mean, I'm really writing this. X squared equals 5 times 45.
Yes.
Okay, what is 5 times 45?
225.
And then square root of 225?
15.
15.
Yeah, I know.
Okay, now let's try with 12 and 15.
Wait, how did you get this?
Yep, because when we find the geometric mean,
Well, no, I know that, but like you kept it x squared.
So I just-
Equals the square root of.
Yep.
It's,
so how do I undo something squared?
So you square. Okay.
Yep, sorry about that. What is 12 times 15, anyone?
180.
Okay, you guys aren't going to be happy with me. You have to give me both a decimal answer and it as a simplified radical, because we need to practice that for next year.
We don't, though.
You do, you do.
Easy answer next year.
We've already done it a little bit earlier this year, remember? You have to think of what's the highest perfect square that fits evenly into 180. So really, if you can't figure it out, just guess and check. So your first one is, first perfect square is 4, right? So does 180 divided by 4 come out evenly?
45.
45? Okay. You want to keep going? You think there's a bigger one that fits into 180? 9? what's 180 divided by 9?
20.
20, so we can start there. So we can write the square root of 9 times the square root of 20. So remember, that would still give me 180. What's the square root of 9?
3.
3.
3 and square root of 22.
Yeah, but can I break down the square root of 20?
No.
4 and 5.
4 and 5. So I'm going to have a square root of 3 times the square root of 4.
2.
2. So I have 3 times 2 times the square root of 5.
I have 2 and 5. I have 2 and 6.
Multiply those out, 6 square root 5.
That's weird.
It is weird. Can we approximate that? Could you guys tell me what that is as a decimal?
Oh,
That's so much
13.42.
2.
13 point.
0.42.
Oh, times.
So approximately 13.42. I promise you'll maybe take me next year that you'll have reviewed this a little bit. So you'll do it a lot next year. You have to take algebra 2.
So,
Either enriched or regular, it's going to be done, and you'll do this either way. Yes, sir.
Enriched algebra.
Do I?
I'm gonna see if I can get you all 4 years from now.
Not for her.
Yeah, it'll be awesome.
so any question where we have to provide answer like that, where we 180 and half a decimal, we need to try and get to the
Yep. Yep, try to do both. And it won't be tests on that. We're just trying to practice.
I'm trying to figure out which ones I need to remember to put it for.
Just try to always do both. Okay? Okay. So now we're going to kind of morph these two ideas together. Last chapter is all about similar triangles. And now we have this geometric mean business. So when you have a right triangle, you guys see this big right triangle?
See.
When you draw in the altitude from the right angle to the hypotenuse, this FH, it creates 3 similar triangles. It's just a property, okay? So now our job is to write a similarity statement for all 3 of these triangles. So there's a big one,
There's 3.
and then the 2 small ones.
There's the big one, that one, and then E, H, F, F, H, G, E,
Oh,
F, G.
Okay, so let's start with the big one. Let's do triangle EFG.
Yes.
Okay, so the big one. Here, I'll trace them out in their color.
They all have right angles. They're the same triangle.
Now let's say that is similar to this left-right one.
E,
So what matches with E in that red one?
E,
E. What matches with F?
H.
H, because I have to do the right angle. And then by default, F. Perfect. Then I have my green one. Okay, now let's go back to the blue. Which one matches with E?
F.
E, yeah. I think it's F.
F.
F. Okay, now what matches with F? The right angle is
H.
H. G.
Is that it?
Yeah, that was it. We just want to write a similarity statement for those 3. Okay. Now let's try find some missing blanks here. So we want to solve for the variables.
C.
So do you guys still see how we have 3 similar triangles? We have the big right triangle and the 2 smaller ones inside?
Mhm.
Okay. So your goal is to always write a proportion using the same variable. So this first one's pretty straightforward, but you'll see what I mean in a second on our next example. So what is a proportion I can write to find y?
Or Y. 12.
Right, so let's look. So if we write 4 over y, do you guys see how 4 is the short leg
Yes.
over the long leg?
Yes.
So now what's my short leg on this?
Y over 12.
Right, y over 12. And you always kind of want to get the variables multiplying each other. If you didn't set that up right, you would have an opposite spot. So now we have a geometric mean, right? Because my means are the same. So I can write y squared equals 48. Let's simplify the radical. So what perfect square evenly goes into 48? 16. 16 times what?
3.
What's the square root of 16?
4.
4. We're at 3. And what is that approximately?
6.9.
6.9? Perfect. We're gonna get really fancy now. Let's see how this goes. So do you guys see how many letters do we have to solve for here? 3. And it gets kind of confusing to keep everything straight. So if you have a hard time separating those triangles in your brain, draw them out. Just draw them out separately, all 3 of them. Okay? So let's start by finding E. That's the easiest one to start with. So what is a proportion I can write to find E?
6 over E, E over C.
So Gabe says 6 over E. So he went short over long is equal to, what did you say? I'm sorry.
E. Is it E over C or E over 24?
Either would work, but I think we would use E over 24.
You'd want to use
Yeah.
E over 24, otherwise you'd have 2 variables, right?
Right, yeah.
Okay.
Yep, so then do you guys see on this green triangle how E is the short leg and this is the long leg? Well, it would have worked once you found what E was. And again, your goal, you'll know you did it right, is you're going to have the variable times itself. So we're going to get E squared. What's 6 times 24?
144.
This one works out nice, because what's the square root of 144, folks?
12.
12. Nice. I'm going to write that in our picture now. This is really confusing. It is very confusing. I'm going to erase these little marks here. But I'm going to leave the 12 because we know what that is. Okay, so again, you can only use one variable in your proportion, and everything else has to be the same variable or numbers. So what's another proportion I can write?
D over 6.
Can we just
30 over
E
D.
was like 0.
You could.
Minus
Yeah, if you want, do you guys want to find D by using Pythagorean theorem?
No.
Is it easier to use the other?
Absolutely not.
Well, let's use proportions today, and we'll use Pythagorean theorem tomorrow. But you're so right, Tristan.
6 over D, D over 30.
Okay, so look, Gabe said 6 over D. So he went short over hypotenuse is equal to, and then he used the big triangle. What's your short leg on your big triangle? D. So far so good. I have D and D. And what's my hypotenuse length?
24.
Close.
30.
30, yep. So this looks good. We'll get a little D squared. 6 times 30 is 180. Did we already simplify this one earlier?
Yeah.
What did we get?
6.
So
13.42
13.42 or 6 times square root
6 root 5 or 13.42. Okay. That's good.
So you just leave it at 6 square root 5.
Yep.
So do you want us to round to the nearest 10 or 100?
I do 10. That's fine. And our last one we have to find is C. I'm gonna have to use the big triangle and then the small triangle on the right side. Because so what's a proportion I can write to find C? Could I do the hypotenuse over the long leg? So I'm going to have 30 over our long leg is equal to, what's the hypotenuse length on this right triangle here? C. And what's our long leg? Nice, 24. $720. Alright, start guessing, checking your calculator. What's the biggest perfect square that goes into 720? It's bigger than 10 squared. So try numbers bigger than 10. Less than 16.
12. 20 to 36.
So what's 12 squared? 144. What's 720 divided by 144? 5.
12.
Yep, 12 we're at 5, which is approximately 26.8. Okay. See how far you get on the next one. Work with a partner and somebody by you. I think it's easiest if you start with x. Start by finding x first. And your numbers are nice on this one. They're all whole numbers. There's no funky radicals. Start with x first.
So we should do this big triangle.
Start by finding x first.
Oh yeah, whatever.
No.
I did. I did use the hypotenuse. So it's a big triangle, which is the hypotenuse. Wait, that one.
So that one there's just going to be regular. So you see on this left triangle, you went short over long.
Yeah.
So on this one over here, you have to find your short leg over your long.
Got it.
Which one's your short leg over here? Yep, so 9 over 12. Yeah, that one is just going to be 1. Yep.
What's 12 times?
Wait, I do.
Oh, my bad.
Obviously, we're trying to write one of these things. So we obviously know that x has to be here.
Yes. Yep. This one's a little different. That's perfect. Yeah. I found y after x. I don't know if that inspires you to find that one next or not.
One.
Are we all confused?
Yeah.
Okay. Did we all get X at least?
I got one.
Is it 16?
I got X.
Yep, you should have got 16.
Yeah.
Okay, so now let's find Y.
This is not going to work. Instead of homework, can we just practice this like together all day?
Together all day.
Yeah.
I'll think about it.
No.
Okay, so to find Y, guys, do you see how I have to use this left triangle? Do you guys agree? Okay.
I just used Pythagoras there.
Yeah, that's
I couldn't
fine.
figure out how else we were supposed to do it.
Okay, that's fine. So I know that I have to use the hypotenuse, right? Because that's Y is the hypotenuse of this left triangle. Okay, so can I figure out the hypotenuse of the big triangle?
No?
Yeah.
Yes. Oh, yeah.
Wait, well, is the biggest triangle similar because it doesn't have a 90-degree angle?
Assume today everything's similar, because that's a lesson. So the top one would be what? 25, right? Okay, on that big triangle, what is Y? The short or the long leg? Y on the big one, guys. 25, Y, and Z.
Oh, short.
The short leg? Okay, so you're going to write 25, your hypotenuse over your short, is equal to,
16.
yes, yep, Y squared what's 25 times 16? 20?
Yep.
Woohoo! All right. Things are looking up. Okay, now to find Z, do you guys see how you have to use that little right triangle? Right?
Yeah.
And the big one? So now this is 20. Okay. So Z is what leg of the little triangle? The hypotenuse. And I know both legs of the big one, so it doesn't matter what you want to write. So now it's just our choice. So do you want to use the short or the long leg?
Short.
Short, so I can write 9 over Z, so short over hypotenuse, is equal to Z, because Z is the short leg of the big one, over, what's our hypotenuse? 25?
For the questions in the book, if we can solve it with the Pythagorean theorem,
Yeah, you
can
solve it
we
however
use
you
them?
want.
But like otherwise, then we're not technically learning the material because we're not using what you're giving us.
I understand what you're saying.
Oh, okay, so like this is preparing you for when you can't use it.
Yep, right. Because no matter what, you would have had to set up a proportion to start, but if you want to find the other two by Pythagorean theorem, you go ahead. That's fine. So we're going to get Z squared equals 225. This one works out nice.
15.
Equals 15. I know this is confusing. We're just going to try it out.